Okay, so we're on the fifth and final one of the ExcelerSize modules. I'm hopeful that at the end of this module, you guys will all be comfortable proceeding forward with the new ExcelerSize capabilities. So what we're going to be talking about during this particular class are the modifiers. And these are a little bit changed from what you're used to working with, but a lot of this will be review because obviously a lot of these are going to be the same kind of things. But I thought it was worthwhile, even if there was no change, and talking through each of the different modifiers in case there was something that you guys weren't aware of as part of the process. So we're going to be talking about the modifiers quantity, area, complexity, work, and uncertainty, and briefly talking on the other modifiers as well. So in general, when you're selecting a modifier, if you don't know and you can't make an informed guess, then you should select unknown. And when you pick unknown, what ExcelerPlan does is it assumes an average value, but it sets the variance to be wider than normal. So your plus or minus range, your risk range, and so on would be wider than normal. If you can make an educated guess, you should make an educated guess. It's kind of like a multiple choice test. If you can narrow it down and say, well, I'm really not sure if this is very high or high, but it seems pretty big, well, pick either very high or high. Don't set it to unknown. Your modifier selections are often driven by the underlying set of assumptions that you're making as part of your estimate. So the modifier selection may represent either a risk or an opportunity based on whether your selection is optimistic or pessimistic. So if you make a pessimistic selection, then your estimate will be higher, and there's a possibility that things will be better than you expected, and so you'll be overestimating. Conversely, if you set it to the optimistic setting, then there's a chance that that optimistic choice will be too optimistic, in which case you'll be underestimating. So clearly, if you're trying to come up with the kind of the optimum estimate overall, what you want to do is you want to balance that. You don't want to always be optimistic. You don't want to always be pessimistic. You want to kind of be realistic, and when you're making guesses, kind of balance it where sometimes you're optimistic, sometimes you're pessimistic. Your alternative analyses that you might do will often involve changes to the modifiers. So for example, somebody may say, well, I'm not sure if we're going to do this in-house or if we're going to outsource it. So those are two different alternatives, and so you're going to have different sets of assumptions that go into that. Somebody might say, I'm not sure whether this particular component is going to be reused from something we already have or whether we're going to have to do new development. So once again, it's a set of alternatives to select from. Quantity is the quantity of catalog items. It is a whole number that are relevant to this HLO. So if we're estimating, for example, pages, it's the quantity of pages. If we're estimating reports, it's the quantity of reports. It may be a negative number. So typically where you would use a negative number would be a situation where you have a change request. And let's say that what you want to find out is what's the impact of removing 10 reports from the design. So the quantity in that case would be minus 10, which is saying that we're reducing the delivered functionality by 10 reports. And so normally where you would do this is either you have a change request situation and there's some kind of a give back, or you're trying to do the net change. So maybe they're removing 10 reports, but they're adding 15 pages. What's the net impact on the effort? Often I use the quantity as something where I can set it to 0 in order to zero out a line without actually deleting all of the entries. So that's handy if I want to be able to do different what-if scenarios where I zero out parts of my estimate, but leave the rest of it in there. And that's useful for two different reasons. First of all, you can go back and forth without needing to retype in all of that information. And secondly, it makes it more explicit. If somebody else is trying to follow in your steps and understand how you did an estimate, if for a particular version of the estimate, you've got the lines in there, but they're just shown with zero quantity. On large projects, the quantity may be derived from build-up worksheets. So what you can do is with ExcelerPlan, you can add as many working worksheets as you want. So you would, just like a regular spreadsheet, you would add a worksheet. Onto that worksheet, you would copy in or you would type in various components. And then when you want to total those up to see how many you have of a different type or so on, you can actually do a total on that worksheet and then carry that total over to the HLO catalog area into the quantity field. When I'm doing the totals, the functions that are most commonly used are sum. So in that case, it's obvious. What I'm doing is I'm summing up the values in a column. Sum if. So sum if would be used in a situation where, for example, in the worksheet, we have pages and reports and interfaces and so on. So I would want to use a sum if, and I would do one sum if and match for page. And then that way it would give me the total of all the rows of type page. Then I might do another sum if of type interface. It would give me the total of all the interfaces. Another sum if of type report. It would give me the total of all the reports. So that's a handy way to come up with subsets of the sum that you can then automatically carry forward onto the HLO quantity field. You can also use sum if s, which is basically the same as sum if, but you have multiple conditions. So in that case, let's say that I wanted to total up all of the reports that were very high complexity. I can do sum if s, where I'm looking for a match on the word report, and where I'm also looking for a match on a complexity very high. That would tell me how many very high complexity reports there are on the build-up worksheet. And then obviously you can do whatever kind of calculations you want. So if there's something that is more complicated than simply summing, you can do those calculations on the worksheet, carry it forward to the HLO catalog sheet. You may also do a build-up of the quantity using the formula for mean. And a standard formula for mean that's simple to implement is to take your best 4 times your expected plus your worst and divide by 6. So let's say that on a build-up worksheet, I had pages, and I wanted to do my estimate in terms of what's the best possible count of pages, what's the expected count of pages, and what's the worst count of pages. So now I've got those 3 numbers. I can then do the calculation of the mean number of pages and carry that mean forward to the quantity column on the HLO worksheet. Because of the fact that the quantity is limited to a whole number, if you're using calculations and the calculations may result in a decimal number, so for example, the mean calculation might, then you would need to use round. So you would use round, parenthesis, the number or the formula, comma 0, which will round the number to a whole number, and then you would put that or have that carry forward to the quantity column. Area is another form of complexity modifier that increases or decreases the assigned function point equivalence for that row based on the selection. It differs from complexity in that it is more objective. So complexity is one of the estimate areas of our estimate, or one of the aspects of our estimate that is subjective. There is no way to have a rule for when do you set something to high complexity or low complexity. Or, I mean, people have tried to do it, but it ends up becoming unwieldy. On the other hand, area does have some fairly unambiguous rules in terms of what you select. Area is also useful because a lot of times it will be used as a sort or a filter parameter by project managers when assigning work. So, for example, they may want to break it out by, break the work down by module because different teams are working on each different module area. The area settings may vary by HLO catalog, but for the ExcelerSize catalog, the available settings are as below, and I'm going to discuss each of those on the following slides. So application service provider means that the software runs on a central server with each client having their own data space and data configuration. So it's your software as a service kind of a model. Internally developed, the software is or was developed by this organization, or we have a situation where customizations have created a situation where the software is completely unique to this organization. So at one point, it may have been a commercial off-the-shelf product, but you've done so much customization over the years that really this is now your own product. It's just as if you wrote it yourself. Vendor package, the software is a commercial off-the-shelf software package. It's typically used with configurations and extensions for each customer. And I'm getting still some background noise. I'm not sure if that's echo or feedback from someone. Maybe if you could put your phones on mute, maybe we'll see if that goes away then. And it sounds like it did. Okay, vendor software upgrade. The component is a customer-specific modification to a vendor package. User experience only. The effort that we're estimating will be for the user experience design only, so it's not for the implementation. And then we have the different modules from complexity very high to very low. These are primarily used for work that involves modification to a large existing system. Typically, what we're looking at is changes to a commercial off-the-shelf software product such as SAP, although they could be used for a large, stable internal application where you're estimating small enhancement efforts. So module refers to an integrated but separately purchased component of the system. So examples with SAP, where we have the R3 core, we have human resources, we have financial, we have asset management, we have production planning, et cetera, et cetera. So they're I don't want to say standalone because they're not really standalone, but they're a distinct and separate part of an overall application. The module complexity that we select refers to how difficult it is to make changes within that module. And it's based on the inherent complexity of the module itself, not the work for this HLO catalog item. So once it is defined for a module, it would normally not change. So for example, let's take the HR module of SAP. We have to somehow decide, based on experience working with it or some other way, we have to decide, is that particular SAP module average complexity, high complexity, low complexity, et cetera. But then once we've decided that and made a note of that, every estimator and every estimate should set the same complexity or same area complexity for work on anything within the HR module. So it doesn't change based on the type of work that you're doing within the HR module. It's a fundamental characteristic of the module itself. And that's one of the reasons why it tends to be less subjective. Because yes, there is some subjectivity in terms of initially setting it, but once it's set, it's stable and it doesn't change. And normally over the course of your estimation work over a few years, you're only going to be working with a handful or a dozen or so different modules. And so it's not that, it doesn't take that long for those to stabilize in terms of what the complexity is. And an example of where you would change it would be either the module characteristic changes. So for example, you've got a complete rewrite of it and the rewrite is much simpler or much more difficult. Or you realize that you just fundamentally set it wrong. So we thought that this was average, we've been working with it more now, and we realize that this is really very high complexity. If you would be doing estimation for a large system, for example, SAP, what I recommend you do is do an inventory of the installed modules, which is normally not that difficult to get, and then assign the complexity settings to each module one time, and then use those settings going forward. So you would do the inventory, you would sit down with the developers who are at least somewhat familiar with the modules, you would assign, use the Delphi technique or some other kind of brainstorming approach, assign a complexity to each one, and then that becomes the set of complexities that you would use. And keep in mind when you're doing this, the module complexities are a normal curve. So what we should see is about 5% should be very complex, about 25% should be complex, about 45% should be typical, about 25% should be simple, and about 5% should be very simple. So when you're doing the Delphi technique, if you're not getting results that are following a normal curve, you may need to shift the results a bit in order to align it with a normal curve. Complexity allows you to adjust for the complexity of this particular HLO catalog item. It's a subjective assessment. Once again, you can use uncertain if you can't make a reasonable guess. Complexity is the complexity of the HLO item involved. It's not the complexity of the work involved, the work that you're going to be doing. I'll say that again. Complexity is a characteristic of the HLO item involved, whether it's a page or report or interface or whatever. It's not related to the complexity of the work that you'll be doing. So for a given thing, for example, a report, complexity will not change over time. So if you've got a report and you're initially implementing it, and then later you're making a change to it, and then later you're making another change to it, that report has the same fundamental complexity for each one of those estimates. Once again, settings follow a normal curve. So roughly 5% of your catalog objects, not for a given estimate, but 5% for the objects within a system, should be very high complexity, about 25% high, about 45% nominal, 25% low, and 5% very low. Once again, that's not to say that on a given estimate that we'll be following that normal curve, because the given estimate, we're looking at a subset of the system, so it's normally not statistical. But for the system as a whole, it would follow that. The central limit theorem applies. So we can use nominal for large quantities with no decrease in accuracy. Technically, the central limit theorem applies when we're dealing with more than 30 of something. So more than 30 pages, more than 30 reports, etc. So definitely if you're over 30, you're fine to just set everything to nominal and you won't lose any accuracy. But in most cases, in my own experience, I find that if I'm dealing with more than 15, I'm probably not going to lose too much accuracy by setting it to nominal. So unless there's a strong reason to break it out, if I've got more than 15, I'm likely going to take the shortcut of setting everything to nominal. Work is used to define what work will need to be done on or with the HLO catalog item. Work does not apply to all catalog items. So for example, the various consulting catalog items ignore the work setting. You can still select a work for those items, but it will be blanked out and it will not be used as part of the calculation. If you ever see work turning into a blank whenever you set it, an Exceler plan, what that's telling you is that for that particular catalog item, work is ignored, and whatever you set it to, it won't make any difference on the calculations. The general areas of work are new, additional, enhanced, test only, or detailed model, and I'll talk about each individually. So if we're setting the work to new, what that's saying is that all aspects of the work are new. So if you keep in mind that most of the catalog objects include not just the part that you see, but they also include the back-end processing and the persistent data support, what that means is it includes the actual object plus the back-end supporting components. So this would typically mean data tables and connectors of some kind, and often calculations and so on. So if we say that a page or a report is new, we're not just saying that this is a new report or a new page from a user perspective. We're saying that we're also going to need to do some changes to the database to add some tables. We're also going to need to do some changes to how we connect to the database and so on. Additional means that it's new from a business perspective. So as far as the user is concerned, it's a new report or new page or new interface, new whatever. But from a developer perspective, we're going to be building from existing backend supporting components, or we're going to be using a cut and paste and modify approach with existing code. So basically what we'll find is that the work to add an additional of something is a lot less, maybe a third of what the work is required to do a new of something. So a lot of times when we're getting change requests or when we're getting added capability to an existing system, what we're dealing with is typically additional rather than new, because more often than not, we're building on something that's already there. Enhanced means that we're modifying something that already exists. It's different from additional because with additional, the thing that we're creating, whether it's a page, a report, or interface, or batch, or whatever, the thing that we're creating when we're done is new. From a business perspective, it's something that didn't exist before, and it does exist afterward. However, with enhanced, there is nothing, from a business perspective, there's nothing new that's created. We still have the same number of pages. We still have the same number of reports, whatever it is. The difference is that we've made some modifications to something that already exists. And when we're looking at the modifications, we've got three different subsets that we can pick from: easy, moderate, and hard. And how they're interpreted behind the scenes by ExcelerPlan is that an easy modification is assumed to be a 5% design change. In other words, the item that we're working on has changed. 5% of the design has changed. A 10% code change, so 10% of the code that implements that thing has changed. At 20% test. So we've had to go back and retest 20% of the code within that thing. A moderate change, ExcelerPlan assumes a 10% design change, a 20% code change, and a 40% test. And a hard change, ExcelerPlan assumes a 25% design change, that's a mistake, a 50% code change, and a 100% test. And let me just make a quick note to fix this slide.
What was that for hard? 25, 50,
yeah.
100?
I'll give it to you again. Yes, so a hard change is a 25% design change, a 50% code change, and a 100% test. So if you'll notice, the pattern here is that ExcelerPlan assumes that whatever the design percentage is, that twice that amount of code will be changed. And whatever the code that's changed is, twice that amount of code will need to be tested.
Mm.
All right?
Yep.
Test only. Test only, the work that's required is just test or just integration and test. So we're not actually writing any code, modifying any code. We're not modifying the design. All we're doing is testing or integrating and testing. Once again, we have choices of easy, moderate, and hard. So for easy integration and test, we're assuming that 10% INT, and what that would translate to is that about 20% of the code will be tested. Moderate, we're assuming 25% INT. What that would translate to is about half of the code will be tested. Hard, we're assuming 100% INT. And what that assumes is that we have to do not only 100% testing of the code, but we have to do 100% integration. So, for example, suppose that we have a library, a set of library routines, maybe, I don't know, graphic processing library routines. If those library routines are installed and in use, and what we want to do is we want to test them, then we would say a 10% integration and test would say that I'm going to test about 10% of the routines. A 25% integration and test would say I'm going to test about half of the routines. A 100% integration and test would say I've got the library routines on a disk. I'm going to have to install them. I'm going to have to hook them up to my existing application. So that's the integration piece of it. And then I'm going to test all of them. So that's the 100%. The last category that we have that we can use is called the detail model. So in the column, we would pick detail model, and then we have the supporting columns off to the right. And for there, what we're going to do is we're going to be setting 6 variables. So the first thing we're going to be doing is we're going to be setting the design modification and the code modification and the integration and test %. And those are the 3 variables that we've been working with so far. Those are the only 3 variables that we're using in the simplified model. And so in this case, we would often use that common rule of thumb of the design change would be X, the code change would be 2 times X, and the integration and test would then be 4 times X. So it doubles and it doubles for our percentages. Obviously, you don't go over 100%. So that way, if we wanted to say, well, we're going to change 2% of the design, we're going to change 4% of the code, and then we're going to do 8% integration and test, you can do that. If you wanted to say, we're going to change the design 0%, but we're going to rewrite 100% of the code, and then we're going to do 100% integration and test, you can do that. You would just set it to 0, 100%, 100%. Fairly straightforward. The next variable is called assessment and assimilation, or AA. And what this variable represents is how much effort will be spent to analyze or to evaluate the code that you're working with to determine whether it should be used or not. So this would be, let's say that we have a set of modules that do part of the functionality of what we want. So they're certainly related to what we want, but we really don't know if they do enough of what we want to be worthwhile. And we don't know how well written they are. We're not sure. Maybe we're not sure what the costs are and what the terms and conditions of use are. So they're just a potential candidate to do some work. Well, we may have to do some assessment and assimilation work in order to understand and analyze that code to even decide whether or not it's worth considering for reuse. And so we need to have a budget for doing that AA work. And the budget can be anywhere between 0% to 8%. And when you're looking at it, you want to take into consideration not just how much analysis time will be required, but also how thorough the documentation needs to be. So if we need to analyze this and then put together a feasibility report and present that feasibility report to senior management, then that's going to take more work than if we're just doing the analysis. Okay, the next category is software understandability penalty, or SU. The question here is, how well written, how understandable is the code? So 10% would be very well implemented, 50% would be very poorly written. When we're looking at this, the things that we want to consider as part of setting the right value are the structure of the code, the cohesion with the application domain. In other words, how well tailored and how well fitted is this code to the application domain where it's working? And also in code documentation. So the number of comments, how well written the headers are, how nicely named are the variables, those types of factors. Then the last category is unfamiliarity. So that goes from 0% to 100%. And the question is, how unfamiliar are the developers with this code? In all cases, lower numbers are better, so lower numbers will be less effort. There's a column for uncertainty, and uncertainty, when you enter something in there, does not impact on the size, the effort, or the cost of your estimate. However, it does have an impact on the spread of the estimate. Most uncertainty is captured by selecting uncertain for one of the other variables. So for example, area, complexity, or work. This particular field is used to capture additional uncertainty beyond what was already captured. So for example, if there's uncertainty around the quantity, you would capture that here. If there's uncertainty around a value that you did set, for example, you think the report is additional, but there's a significant uncertainty around that setting, then you may capture it here. And also you would use it if there's uncertainty about the HLO selection itself. For example, you think it's a report, but it could be a page. You think it's an interface, but it might turn out to be a service, that type of thing. Then I'd mention that in addition to these core elements, there's some additional ExcelerSize fields that I'll touch on briefly. So requirement ID is what we use to map this particular HLO catalog line item to a requirement and a requirement traceability matrix. So it's used for traceability purposes, and so that we can consolidate up and provide traceability in terms of effort, cost, and so on. Size and function point equivalence is the size and function point equivalence. So that's a calculated field by ExcelerPlan. It's not an input field. And if you ever want to compare, or if you ever want to look at what's driving the work and so on, you can use this to determine, okay, so if something is 1/10 of the function points of the entire project, it is going to represent 1/10 of the work. So this is the function point equivalents are the building blocks of how we're calculating size. Then core hours are the hours spent by any team member working on the primary implementation activities. In other words, the core activities and the work breakdown structure. So it's not limited to the programmers, for example. It wouldn't be accurate to say core hours are programming hours. That's kind of, that would be a simplification, and it's not exactly accurate. More accurate, it would be more accurate to say that core hours are all of the people who are working on doing the development work. And so the things that are excluded from the core hours are the work breakdown structure activities that are not directly part of building something. So that could include the security folks, it could include your project management activities, et cetera. Comments are just comments about the selection, about that you made. But this is also a good place to put formulas that help derive values for this row. So if you're using a formula, you can actually put that formula in that row, and then that way it makes it explicit how you were calculating out the quantity or whatever. Status is used to update the earned value, to update the forecast at complete, and to update the risk. So valid values for status are pending, started, complete, and accepted. And in some cases, as the project goes forward, if you're using this capability, you may need to split one estimate line into multiple lines. So for example, let's say that as part of my estimate, I estimated 10 reports on one line. So quantity was 10, and the catalog item was reports. But now we're in a situation where 5 of those are not started and 5 of those are complete. Well, I would need to split that line into 2 lines so that I could show 5 with a status of complete and 5 with a status still of pending. All right, before I jump into that, any questions on the catalog modifiers?
Yeah, William, this is Shannon. I have a question. On the detailed model selection.
Oops.
So
Okay.
you talk about 4 different pieces of detailed model. Hang on, I think I lost my train of thought.
Okay, and it's actually, the detail model is 6 different pieces. We have the 3 that are the same ones as the other models, which are design modification, code modification, and integration and test effort, each of which will vary between 0% and 100%. And then we have the assessment and assimilation effort, the software understandability penalty, and the unfamiliarity, which is familiarity or unfamiliarity of the team or the developers with the code.
Okay.
Okay, other questions?
So where do you input that information? I just see detailed model as a work object.
Then off to the right. Let me see if I can.
Oh, I see. Okay.
You got it?
Columns. I see. Okay, thanks.
Yeah. Yeah, if you pick detail model and then you don't go off to the right and enter numbers, then you'll have 0 for your core hours, because until you enter something, you won't really have any way to do the calculation build up.
Okay.
And by the way, where I use the detail model quite a bit is anytime I'm dealing with unusual situations. So, for example, somebody says, well, what we want to do is we want to estimate the effort to port this system from natural over to Java, and we're not going to make any change in functionality. We're just going to do a straight port. Well, the best way to do that estimate is using the detail model, with 0% design change, 100% code change, and so on. I also, if I'm dealing with very large quantities of something, I'm likely to be moving to the detail model. So if somebody tells me, well, you know what, we're going to have to test 1,000 pages, I'm likely to want to use the detail model for that, just because when you use the other models, you're going to end up getting approaches and efficiencies and so on that you want to capture using the detail model. And the inaccuracies that you would get that would be kind of smoothed out with a normal estimate, when I'm dealing with quantities of hundreds of something, those inaccuracies add up. And so the detail model will help me smooth out or get rid of those inaccuracies.
So this is something that you sort of figure out as you're doing the interview process, just based on how the conversation's going.
Yes, basically when I'm doing the interviewing process, what I'm doing is I'm trying to, number one, make sure I understand all the different components of work. And then in my mind, I'm mentally doing the estimate as I'm doing the interview. So let's say that somebody's talking about 3 reports and 2 pages, I'm just trying to figure out, are these going to be modified? Are these complex? Or, that type of thing.
Mm-hmm.
Let's say somebody's talking about, well, we're going to write 300 new pages. Well, now I'm thinking, okay, I'm going to have to get into the design, into the detail model. And so I'm trying to understand better what's their approach, what settings do I want to use for SU, for UNF, unfamiliarity, et cetera. And it's also the reason for, this would also be situations where you may have to have a follow-up meeting, because you have your initial meeting, and then you go off to attack the estimate, And then you realize that, gosh, the best way to estimate this is to use the detail model. And I never really thought of asking those related questions. So I want to go back and ask a couple follow-up questions to help me apply that model.
So if you modified applications experience in your input environment and you basically indicated that it was low or very low, you wouldn't necessarily reflect that in the unfamiliarity, or is that just another level lower as far as in the detail?
Yeah. When you're setting it in the environmental variable, you're setting it for the project as a whole.
Right. Okay.
When you're setting it here, you're setting it for specific components of the project. So where this would typically come in is this particular set of modules or this particular interface. People are going to be looking at it for the first time.
Yeah.
Or this particular report. Well, we change this every year, so we're very familiar with that report. Any other questions on anything in the settings? Okay, let's go through some student exercises. So project 1, we need to add a new report to the SAP HR module, which was previously assessed as a moderately difficult SAP module. What modifiers would you use? So Shannon, you want to give us a shot?
I need to think through this, and I need to open up a workbook. So hang on. So one moderately difficult. One internally, I guess what are you looking for? Like all rows, one internally developed?
I'm looking for if you look at the headings on the ExcelerSize thing, I'm looking for quantity, I'm looking for area, I'm looking for complexity, yeah.
Okay, that's where I was going because I was like, we just really focused on one thing in all the rest of the training. So, I would say one internally developed report internally developed report average enhanced. Moderately difficult.
So the work?
One internally developed report with average complexity, enhanced hard work, and average uncertainty.
Okay. So what I would probably pick would be one module typical. So that's our quantity 1, and then module typical. And then uncertain complexity, because we really don't know, and we can't really rely on statistical averaging at this point in time. And it's an additional report because from a user perspective, it's new. but I'm making a reasonable guess that it's going to be pulling from existing tables and so on. And then an average amount of uncertainty, nothing, I'm capturing the uncertainty by picking uncertain complexity. Okay? Everybody follow that? And let's go back on mute again. I'm getting that echo again. Okay, student exercise 2. So project 2, we have more information about the report. It's an existing report, after all, we've discovered, that is highly complex, with 10 pages of source and derived data. The modification involves changing the footer to comply with a new privacy policy. So now what modifiers would you use? Augustine? And you might be on mute.
Sorry.
Okay.
Yeah, I was I was on mute. Let me see. So it's the 10 pages are throwing me off there. One report, high complexity. And we should use a quantity of 10 somewhere else. 10 pages.
Okay, let's take a look at what I've got here. So I've still got one module, typical, that hasn't, one, and then module typical, that hasn't changed. High or very high, it says highly complex, but for me, a report that has 10 pages of source and drive data, I'd probably move it into the very high, but that's a judgment call. However, the report is enhanced, the work is enhanced easy, because the only change that we're making is a very simple modification to the footer. So although the report itself is very high complexity, the work requirement is enhanced easy. And by this point, I would probably set the uncertainty to very low, because we've done quite a bit of analysis work, and this particular line item is very clearly understood in terms of what needs to happen. Project 3 involves estimating the effort to add 35 new reports to an existing bill payment system that was purchased 20 years ago, but is now highly customized to the organization and no longer vendor supported. You can obtain the following additional information by having the implementation team work for the indicated number of hours, and these will be on the following slide. So my question for you is, which items as estimators should you ask for, and why or why not? So Gail, they tell us that we can have a list of all the report names, those 35 report names, with 2 hours of work by the team. Do we want to ask for that, or do we want to tell them to forget it?
I think you do, because unless you do have that inventory, it would be good to have an inventory that you could base it on.
Excellent. So yes, that list of reports, which is obtainable without very much work, supports our basis of estimate, and later will help the project management team with scope management. So there will be less disputes about was this report in the initial estimate or not in the initial estimate. So very good. They tell us that they can give us a description of the report layouts, including field mappings to the database, with 160 hours of work. So John, should we ask for that, or should we tell them to forget it?
Description of the report layout. Yeah, I think you would need that description in order to make the modifications, the necessary modifications.
Okay. My recommendation would be to say no. What we're seeing here is design work, which, yes, at some point in time, someone's going to need to do that. But it's not required in order for us to do estimation. We're above the central limit theorem, so we don't really need to assign any complexity, detailed complexity to each of these individual reports. We can set all 35 reports to a nominal complexity. And we should be able to estimate this before the team expends that 160 hours to do this design work. So Michelle, we can ask for a ranking of the reports by complexity and categorization from very high to very low complexity. And they said they could do that with 35 hours of work. Should we ask for that?
No, because of central theorem.
Yes, but it's a little bit of a trick question because the answer is no, as you say, if this is only used for estimation purposes because the central limit theorem applies. But here's where the trick question comes in. The answer would be yes, if the business unit will be using individual report costs to prioritize or remove reports that don't offer enough value. So one of the things we want to keep in mind is what's the purpose of our estimate, who's going to use it for what purpose, because that will often drive our estimation choices. So in this case, for example, if we did do the ranking from very high to very low, now we can say, you know, this report's going to cost you $15,000 and this report's going to cost you $3,000. And a business unit can go through and say, this one's worth it, this one's not, you know, if they choose to do that. Project 4 involves verifying that 100 browser screens for an internally developed application work correctly on 5 different browser versions. The business unit wants each screen to be individually verified, so they don't want statistical or something like that. What modifiers would you use? Gail?
Let's see. I would do 500 user experience only. Page. And the complexity would be very low. And the work would be test only easy. And uncertainty would be very low.
Okay. Very close to the, actually, and you know what? There's a mistake here too. This should be 500. You are correct. It's not 1,000, it's 500. So let me make a note of this screen to fix this. So it would be 500 internally developed pages. Remember that the complexity of the thing we're working with is not related to the work. So in this case, it would be average complexity because of the central limit theorem again. I would say, instead of saying user experience only, which is really saying that what we're looking at is the design elements of those pages, because we're really not looking at design, I would say keep them as internally developed for the area. Low uncertainty, but then in terms of the work, here's where the key is going to come in. For the work, I would use the detailed model, and my settings would be 0% for DM, because I'm not going to change the design at all. 0% for CM, for code modification, because I'm not planning to change the code on those screens at all. Somewhere between 2.5% to 5% integration and test. And this is really a judgment call based on how much work you think it will be required to set up and verify that the pages are working correctly. But once again, this is just because I've done this kind of estimate before, but it's going to be a small number in the INT column. I would set AA to 0% because we already, there's no question about what we have to do here. I would put the SU setting down to 10% because on the assumption that we don't really care about the underlying structure of the code and so on. We're not going to have to get into there. We're not really worried about understanding the business logic on the pages. All we really have to do is just go through and make sure that they're functioning correctly. So I'm going to set that low. And I'm also probably going to set UNFM to 0%, once again, because the nature of our work isn't going to require very much familiarity. And because we're doing the same thing 5 times, whatever unfamiliarity we have by the time we've done it a couple of times is going to go away. So I'm going to probably attack this using the detail model settings as indicated. Everybody follow kind of the logic of how I approach that? All right. Well, we've got 3 minutes for any final wrap-up questions.
Well, this isn't a question, but it's an observation. I'll be referring to these notes or your slides a lot more than I thought.
Well, you know, and John, you and Michelle in particular have a real advantage because it's one of those things where you're probably getting a whole different level of stuff out of this than you would if you'd heard the same presentation a year ago.
Oh yeah, a year ago we would have been glazed over.
Yeah.
Would have been like, what?
even more glazed over.
Okay. Well, thanks, you guys. I enjoyed doing the training for you, and I'll get this presentation fixed and out to you today.
Thank you very much.
Thank you.